Hello, welcome back to PureSQL tutorial. In this tutorial, we're going to continue to discuss about PureSQL control structure. And last time we discussed about already we completed this selection, and then here we're going to discuss mostly on iteration. All right. So before that, let's ask me a question. So my question is, can you find out the squares of number from 1 to 10? Write a program. That program is going to give me 1, 1, 2, 4, 3, 9, 4, 16, and so on, 10, 100. So this question, what we are saying, we are iterating. We are doing the operation. The operation is that you are squaring. So whatever value we get, we square it. Okay, we square that number. But to get a value from 1 to 10, you have to do in some kind of loop. Okay, you continue to do that operation 10 times. Now I can also ask you, you can find me a square from 1 to 100. Everything can be done. Okay. So that is what you use a iteration. The iteration control is used to solve this kind of questions. So let's try to do some simple example how those things are done in PureSQL. Okay. The basic structure of PureSQL is called loop. Okay. So what I'm going to do, I'm going to write loop, end loop, and whatever number of statements I'm going to write inside this thing is going to loop indefinitely. Okay. So it's going to loop indefinitely, but I need to give one of the statement, whatever I give, I need to give a condition which will allow me to get outside of this loop. Okay. Remember, whenever you have this loop and end loop, if you do not give any condition when you go out, then it's going to run infinitely. Your program will never come out. In this case, this is an example where I'm going to print all the inside loop forever, because here is my loop, end loop. Where is the condition to get out? Essentially, there is no condition to get out of this loop in this example. Okay, and this is a case where my program is going to run indefinitely and will never come to line number 8. So to make that one not happen, right? That means to allow that, we need to add some kind of condition. In the next example, what I did inside that loop, so this is the loop and this is the end loop, line number 10. I increment the value of x, and then I put a condition here. Okay, if x is greater than 3, then exit. Whenever it's going to come and exit, then it will go on and find out what is the next end loop. So it will go to the control will go after the next end loop. Let's take an example. So this is a loop, this is end loop. Okay, so here is an exit. So what is going to take? It's going to take, like, whenever it's going to get and say statement 1, statement 2, and after that I have an exit. Okay, then this whenever the control hits exit, then it will just simply go to the next statement after the end loop. Okay, so this is how looping works on any programming language, and then the same thing also works here. So in this case, in this example, we take this variable and then we give a condition. So that means this loop is going to loop for 0, 1, and 2, 3 times. Okay, so whenever it comes, sorry, I'm sorry, it's loop for 0, 1, 2, 3. So whenever the value is 4, 4 is greater than 3, therefore it will come to this exit and it will bring to line number 11. And then it's going to print that one. Okay, so this is the very basic loop syntax in PureSQL. Okay. This, this x greater than 3 exit, all these things can be written in a more elegant way by something called exit when clause. Okay, so whatever that previous program that you have seen is going to be written more elegantly like this. What I'm going to do, instead of putting this if and this condition, I'm saying exit when. So I start the loop, end loop. So I'm going to increment the value of x, and I'm saying that exit when x is more than 3. It's just like the syntax is more like an English-like language. Nothing to worry about this. No condition, nothing. So exit when x value is more than 3. And after this exit, this thing, the control resumes from line number 13. Okay. Another statement we have is called continue. So let's take an example of continue. So whenever you say continue statements, see, like now exit statement is going to take you to the end of the loop. The reverse happen in continue. The continue, whenever it hits the continue statement, is going to take to the beginning of the loop. Okay, so we have a loop, end loop. Whenever you enter, whenever you see exit, when the control is going to see the exit statement, is going to just simply take you back to the end of the loop. Instead of that, whenever the control says another statement called continue, then it's going to bring you to the beginning of the loop. The similar thing happening here. So what we're doing is we are having a axis number and then we say loop. So line number 4 we start the loop, and line number 16 we are ending the loop. And in between, what we are doing, we are incrementing the value of x to 1, and then I have a condition here. If x is less than 3, then don't do anything. No need to go to line number 12, right? So for x is less than 3, you from line number 9 you go back to line number 4 again. So let's say the first value of x is equal to 0, and then now it becomes x is equal to 1. So the value of x is equal to 1 at line number 6. Since x is less than 1, so this condition is true. Therefore, it comes to this if loop. And inside that if loop, I'm saying continue. So that means I'm going to go back to line number 4. So that means line number 12, 13, 14, 15 is not going to be executed right now. So then the value becomes 2. Again, 2 is less than 3. Again, continue. So comes back to line number 4. Then become 3. Whenever it becomes 4, that means x less than 4 is less than. So this condition is no more going to be true. Therefore, it's going to continue to go to line number 12. So line number 12 is going to print whatever this thing, and then to exit. So basically the value of x is 4 now. Is 4 is equal to 5? The answer is false. Therefore, it's not going to exit right now. Then it comes to this line number 16, and then again it's going to loop back. I'm going to start the loop again, and x is equal to 5 right now. X is equal to 5, then this condition is not going to be true. That comes here and print 5. And then now this condition is going to be satisfied. So now it hits an exit statement. So therefore, it's going to come back to line number 18. So that is how using continue. So again, this continue can be written a little more elegantly by using continue when. Exactly the similar manner, whenever we do exit when, we can do continue when. So continue when means at line number 17, if this condition is satisfied, then it goes back to line number 4. Okay. So if this condition is not satisfied, then it keep continuing. And then line number 10, if say exit. So if this condition is satisfied, then comes back to the loop. Otherwise, the loop is going to come back, and then once the loop is complete, then again it's going to try to loop again. So basically, this continue and then exit when, these are the clause, these are the things that basically ask me whether I need to go to beginning of the loop or end of the loop. It's a very powerful features. By using this, you can write a lot of complicated logics. You can make a lot of complicated logic into programming units. The next thing is that we can also label a loop. Basically, before you write a loop, we can give a label by 2 greater than 2 less than sign. Okay. By giving that, we can say that the name of the loop is x. Then we can say inner loop. Similarly, inside a loop, we can have another loop, and so on. Okay. So as many number of loops that you want to nest, you can do that. So in this example, we have 2 loops, and in 2 loops, we are having inner loop and outer loop. And then what I'm saying that I'm giving a condition here, line number 14, that exit which loop, inner loop or outer loop. When this condition is satisfied, you exit inner loop. When this condition is satisfied, you exit outer loop. Okay. So basically, this will basically give you more control when to exit what kind of which loops. Okay. The next one is, so basically we decide loop and loop. That is a basic structure. And next is while loop. The while loop is something similar to other programming language. While then a condition, and this condition is going to loop multiple times using this value s is I into I. So whatever this is this, right? Basically this is the answer to the question that I asked in the beginning. That write a program which is going to give me a square of 1 to 10, and this is the program which is going to give to square from 1 to 10. Here I am using this while loop. We can also do a simple loop, and then you can square and then end loop, and you would exit this loop when x value is greater than 10. Okay, so something the same thing can be done instead of while loop, just by simple loop and end loop. Right. The next thing that there's another type of loops Oracle we give is called for loop. So just take a look at what is a for loop. The syntax is something like line number 4 for I in 1 to 10. See, I do not declare any variable called I. So whenever I give for, that means Oracle's PL/SQL gives you a temporary variable whose name is I. That's called the counter. Okay, that counter is a number. Those things are implicitly defined at the for loop. And then this is called 1 to 10. This is called lower bound. This is called upper bound. Okay, so lower bound and upper bound, and then I do the square, s is equal to I into I. So this again, the same question can be done using a for loop. Okay, so for loop, I 1 to 10, and look, like I'm not basically incrementing the value of I. The value of I automatically incremented I is equal to I plus 1 because of this. Okay, so because of this, the value of I incremented because of this for loop. For loop takes care of all those things for you. Okay, you just write the code, whatever you want to, whatever your logic. In this logic, I'm going to just square whatever number I get, I just square it. Okay, so this is called for loop. And then there's another for loop, another example of something called reverse for loop. And here's an example of reverse for loop. So what I'm going to do, I'm going to write just a keyword called reverse, as I have shown you here. The keyword called reverse, 1, 2, 3. So in this case, what this is going to return is going to return 3, 2, 1. What is going to happen? The first time I value will be the whatever this upper bound is. Okay. So basically, this is equivalent to writing for I in 3, 1. Okay. The same thing. So basically, reverse basically going to start, whatever the upper bound. So this is the lower bound, this is the upper bound. In case of reverse, those upper bound, lower bound will change. And in this reverse case, actually the value will be decremented. Like initially the value of I will be 3, and then the next time it will be decrement by 1. Okay. So in this normal case, it will increment by 1. It will start from the lower bound. In reverse case, it will start from the upper bound and it will decrement up to whatever value that we have in the lower bound. Okay, so some more example here. So this is what I show you here, that for j it can go from -5 to 5. So that means this is the lower bound and this is the upper bound. So you're going to start j is going to start with -5, then we'll add 1, so it's become -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. So this is going to run 11 times. I'm not doing anything here. It's null means I'm not doing anything. But you can write whatever square and all this thing that you want to do. You can do it at number 10. Okay. So this example where these bounds are numerical literals, so numerical values, and there is no reason why you cannot make these bounds as a variable. And this variable, for example, in this case, line number 15 is another for loop, it's the reverse for loop, and my first is 1 and last is 10. Okay. Since this is a reverse for loop, therefore the k initial value will be 10, whatever is the upper bound, and then k will be decreased by 1, 9, 8, 7, 6, 5, 4, 1, and then whenever it's going to reach the lower bound, which is 1, then the loop will going to stop. Okay. So in this case, what I'm saying, the idea behind this code is to show that the upper bound and lower bound can be variable. Not only that, the upper bound and lower bound can be also some expression. So upper bound here is 0, it's a numerical literal, but whereas the lower bound is a numerical literal, but the upper bound is an expression of whatever this value comes to, high by low. So 100 by 12, whatever the trunk value is going to come, that is going to be the value of upper bound. Okay. Not only that, we can also set the upper bound based on number of rows at the runtime. In this case, what I'm going to do, I'm going to select from employee table and how many employees I have. So whatever that value, I'm going to put to a variable called employee count. And then that is the employee count I'm going to use from I is equal to 1 to whatever this number. Let's say this number is 24. That means this loop is going to loop for 24 times. For whatever day, if there is, some employees are retired or some employees are gone from this company, and then employee number is, say, there are 10 employees are there. On that day, this for loop is going to run 10 times. Okay. So this is what I'm saying, that upper bound, lower bound can be also varied dynamically, and then that can be based on a select query. So more for loop examples. So now let's do some exercise. So what is the output of this column, this piece of code? Let's try to do. So for I is equal to 1 into 3, right? So this I means whenever I say this I, this is a special variable that is defined by Oracle implicitly, and this I is basically a number, and then this I will be automatically incremented inside this for loop. But remember this, you do not have any programmatically, you cannot control, you can assign any value to I. Okay, so here this program is going to give me an error because in else block I'm trying to manipulate the value of I. No, this is not allowed. Let this I, whatever this value that we got for I in 1 to 3, that is a Oracle internal variable. You do not assign anything, you just use it. How do I, for example, in this case I'm just using that variable, that is fine, but you cannot assign anything. So this is when this program is going to give me an error. Okay, so let's try to figure out what is the output of this program. Okay, so this program, what I'm trying to do, I'm basically creating a a date, which date is basically an array of date list, and this is a PL SQL table. So that means something like this, and this is the dates. Okay, then for J, so when J, so J is a PL SQL implicit variable. It's called counter variable, and this counter variable is starting from 1 to 3. But look, I'm not assigning anything, but I'm just using whatever the value of J. Right, to the first time the value of J is 1. So therefore, what I did, 1 into 5. So fifth element of this array dates. So 1, 2, 3, 4, 5. Okay. So this element is now today, sysdate. Whatever the date today we have is assigned to sysdate. So this is this because so here I'm using J. I'm not assigning J unlike in this case. Okay. So this is why the output will be that, and then the line the fifth element of this array is going to be populated. Then again the 10th element, because when J value is 2, then 5 into 2 is 10, and again 15 element. Sysdate, not so sysdate. Okay, so this is how this is the output of this program. So let's try to do one more thing. So what is the output of this program unit? Okay, so in this program unit, what I'm going to do, this is a for loop, and inside the for loop, I'm going to start from 12. So obviously the lower bound is 12 and upper bound is 10, right? So in this case, the lower bound is already more than the upper bound. So therefore, this for loop is not going to be, the condition has already well passed. Basically, the idea behind for loop for I in 1, 2, that means start with 1 and go to 2 by incrementing. And for I in reverse, 1 to 2, that means you start with 2 and then go back to 1 by decrementing. So now you look at this. This is not a reverse for loop. This is a standard for loop, normal for loop. So you basically, what I'm saying to this compiler is that, okay, you start I with 12 and you increment by 1 and go to 10. This is absurd, right? Because you cannot, even if you increment, you cannot go to 10. This can be a good line if instead of I reverse. This can possible. Because, okay, in the reverse, what I'm saying, I start with 10, with the upper bound, that's 10, right? And then it can go back to 12. Okay, so that is also possible. Okay, so this output. This is nothing. No. So this for loop is not going to work, and just this for loop will never be traversed. Okay. Some more example. What is the output of this? For I is 1 to 3, and then you this thing. So remember, like when this I is an internal PL SQL variable that Oracle defined for, which is a number, and it will increment by 1 each time this loop is traversed. The scope of I is only available during this loop. That means outside this loop, if I want to access the value of I, is going to give me an error. So inside this for loop, we can access. So this is what we discussed. So the iterative control, summarization that we started with loop, end loop. Then we use some when clause to get to make our loop exit out, to basically to create an exit criteria so that we can get out of the loop. Then we define a while loop, and then for loop. And for loop, we also seen a lot of examples using this lower bound and upper bound. And we can label the loops so that we can, you can control the loops even better. Okay, so this is all about your iteration control. Using selection control and iteration control, you can make your logic more robust. So essentially, whatever these kind of rules that we give, like to start with this question, right? So what kind of this question? So these things can be, you can use this PL SQL control to complete the program.